What if I told you can just copy some lines of code that I prepared just for you, for free, drop them into your OpenGL Vulkan or DirectX projects, and it will just improve your visuals with almost no performance penalties. This is no clickbait and there are no hidden things. You just need to understand how it works to apply it correctly, so don't just skip to the end of the video. It will only take 5 minutes to get your game to look from this to this, or this, and it will finally make your 3D game look next level. Let's start with the problem. We have a game here, and there are many light sources, and you can see that it doesn't look very good. Why is that? Well, you know that each color has 3 components, red, green and blue, with values in between 0 and 1. But what happens if you have many light sources? Well, the lights will probably add up to become more than 1 in some places. Let's look at an example. Let's say this area has an accumulated light value of 1, while this area has an accumulated light value of 1.5, so clearly much brighter. But since there can be colors with values higher than 1, both areas will just be displayed as having the same maximum brightness. This is called clamping, because you clamp the values bigger than 1, and it is bad, because you basically lose information. This area is brighter, but you don't see it as such. The same problem happens in photography, because it is essentially the exact same thing. So here is the solution. While working with values in the shader, they can have values greater than 1. The problem is when you want to display them to the screen. So after we do all of the calculations, before displaying the final result, we apply a function that slowly increases towards 1, but never goes beyond it. This function is called a tone mapper, and it will not only solve the problem of clamping. You see, bright colors tend to become white, so this tone mapper, for example, makes very bright objects go towards white, and various other tone mappers make the scene look different in various ways. It is just like adding an Instagram filter to your image. At the end of the video, I will give you a link to all the tone mappers that I showed, but let's see how to apply them correctly first. There is a chapter about gamma correction on learn.opengl.com that you should read, but briefly, whenever you load a texture and you want to use it, raise it to the power of 2.2. Also, if you have things like color pickers, you should raise those colors to this power in the shader before using them. Then, you do your things normally, and finally, before displaying the colors to the screen, raise the final result to the power of 1 over 2.2. I know this sounds weird, but it is explained in the gamma correction chapter in Learn OpenGL. Now, some tone mappers already have this last step integrated into them, some don't, so you need to do it explicitly, but don't worry. Again, each tone mapper will have an example where I'll show very clearly how to use it step by step, so you just need to copy this code and use it. Okay, 2 more things before I show you all the tone mappers, and the first one is exposure. Usually, before applying the tone mapper, you multiply the final color with a constant. This is used to globally make the image darker or lighter, as you can see here. And there is one last thing you need to take care of before adding the tone mapper. So, as we already discussed, lights will add up to have a value more than 1, and this is a problem if you use deferred rendering, or basically any kind of secondary texture buffer. You need to make sure those textures can store values bigger than 1. So basically, if you write color values before applying the tone mapper into a texture, that texture needs to be able to store colors bigger than 1. But that's as easy as specifying that you want a different buffer format for that texture. I recommend this buffer, for example, if you don't use alpha values. Instead of having an alpha value, it will use those bits to be able to store bigger values in the red, green and blue components while still being lightweight. Okay, now we finally get to the tone mapper. So after you finish all your lights calculations, you apply the tone mapping function of your choice to that color. And then you do that gamma correction thing after, if needed. Again, I will write for each tone mapper if that is the case. So, first of all, we have the ACES tone mapper. It is very popular and it is used in the film industry. And it looks indeed very filmy. The best part about it is that it makes very bright areas turn white, while its downside is that it is maybe too dramatic. Next, we have AGX. It has 3 versions, the neutral one, the golden one, and the punchy one that I like. Next, the tone mapper from the game Uncharted. I use this one right now. It is cheap and looks very good. Finally, Zcam is very neutral, making it easy to add other effects. So you might like that, but it is also the most expensive one. Now, this isn't really a problem, as long as you don't have overdraw. But you can very easily solve that with a trick that is probably even easier than this tone mapper thing. Check this video out if you want a trick to double your OpenGL's game performance. See you there!